Fluid refers to viscous liquids or gaseous substances. Newton noticed that normal liquid or fluids have a constant viscosity flow. Water acts like a normal liquid with constant viscosity within this temperature range and take on the shape of the container into which they are poured. These are known as Newtonian fluids. However, some fluids disobey this rule. These are known as non-Newtonian fluids. Fluids can be classified into two categories based on their viscosity, which are rheopectic fluids and thixotropic fluids. Yet, both of these are time-dependent non-Newtonian fluids.
Rheopectic fluids are liquid or gases exhibiting increasing viscosity with tension over time. These fluids exhibit time-dependent dilatant behavior. As a result, these fluids belong to a unique class of non-Newtonian fluids. On being stirred, they also reveal a greater viscosity. In other words, shaking the fluid causes it to thicken or even harden. Furthermore, the higher the shear tension, the more viscous the fluid gets. It's because these rheopectic fluids' microstructures are built through contents shearing, known as shear-induced crystallization. Printer ink lubricants, various of gypsum pastes and other products are typical examples of rheopectic fluids. But the most common example is cream. Cream is originally watery, and after we whisk it turns thick and viscous. When enough shear applied on cream, it will turn into fluffy solid. A thixotropic fluid is non-Newtonian fluid that shows time-dependent shear thinning property. The fluid becomes less viscous when stress is applied and recovers to its original viscosity in a fixed time period once the stress has been removed. A thixotropic fluid is a fluid that takes a finite amount of time to attain equilibrium viscosity when introduces to a step change in shear rate. The longer the time the fluid goes under shear stress, the lower the viscosity. Fluid becomes easier to flow. This thixotropic pseudoplastic fluid requires certain time to return to its equilibrium viscosity when shaken, stirred, or stressed. Examples of thixotropic fluid in foods are manuka honey, ketchup, and yogurt. Example of applications for thixotropic fluids are the thickening of food, stuffs, and medical products. Toothpaste is thixotropic, which allows it to be squeezed out of the tube, yet retain a solid shape on the brush. Ketchup is frequently thixotropic. Another example of thixotropic fluid is synovial fluid found in joints between some bones. The graph shows the viscosity against stress over time.
In conclusion, both rheopectic fluids and thixotropic fluids are non-Newtonian, time-dependent, and can be liquid or gases. We can see the differences between this based on their viscosity and behavior.